So we start with the source transformation. So the first problem in a source transformation, we need to convert uh, all these circuits to leave only the 4 ohm resistor. So the first one, I think, is just straightforward. It be converted to we convert the 6 volt and we convert the 6 volt and the 10 ohm to a current source and a resistor. So with circuit 1. So we have here becomes one source 0.6 amp in a parallel with a 10 ohm resistor. 10 ohm, and this becomes the 4 ohm resistor. For the second one, we just combine the 6 amp and the 10 volt, so it becomes 60 volt in series with 10 ohm. So here we will have the 4 ohm resistor. In the last circuit, we need to keep the 1 ohm resistor because there is a dependent variable here. So we convert the voltage source and the the 5 ohm resistor to a current source, which is equal 2 over 5. So it becomes 2 over 5 Ix in parallel with the 5 ohm. You can see here I cannot combine the 1 ohm here. I cannot combine the 1 ohm here resistor because there is Ix. If we do any combination here, we will lose the dependent variable. And also for the 4 ohm, we cannot combine it with V1 ohm because we have asked to find the equivalent circuit. We are asked to find the equivalent circuit here. So here it becomes the 5 ohm and the dependent sources. So here it's only we cannot go further in this. So for the second one, we need to find the current I using source transformation. So here, what we have here, we have a voltage source and a current source. So first of all, we can combine these 4 and 7. Then we can convert them to a current source and a resistor equal 11. So here this becomes, we keep the current source 3 amp, and here we will having our 5 ohm resistor, and this is I, and this will be converted to 11 ohm, and this current source becomes 2 up, it equal 9 over 11. Now we can combine the 3 amp and the 9, the 3 amp and the 9. So together they become, our final circuit will be 5 ohm, and the current that we want to calculate is I here, and this becomes 11 ohm, and the current source here will equal 3.818 amp. So from here we can find that I will equal 3.818 times, we just apply current divider, times 11 over 11 plus 5, so this will equal 2.625. 2.625 amp. We go to the third problem. The third problem says that we need to find I using source transformation. So here we will leave this part, then we will do multiple source transformation here. So the first thing that we combine the 12 volt and 3 mega ohm to a current source. Then with a parallel resistor 3 mega ohm, then we combine the two current sources. Then we will find that this will equal to a current source 1 amp. So 1 amp after we combine them. So 1 microamp in parallel with, because 3 mega ohm and 2 mega ohm, they become one parallel circuit, one parallel resistor equal 1.2 mega ohm. Then here we will have the 13 mega ohm and the 7 volt. Then here we convert this to a voltage source and a resistor. This voltage source becomes minus plus downward because the direction of the arrow is downwards. Here we will have the 30 mega ohm, and here this is our 7 volt, and we do not forget that here we have the 1.2 mega ohm, and the voltage source here is equal 1.2 volt because 1.2 mega times 1 microamp. So here we can find that our current will equal minus 8.2. It will equal minus 0.02. Remember that the two sources are in the same direction. 1.2 plus 7 over the resistor 14.2 mega ohm. So this will equal minus 0.578 microamp. Remember, because I in this direction, if you notice, I is in this direction. True. So the current here, the original current 7 and 1.2 will cause a current to be opposite in this to this direction, to this current. We move to the next problem, which is 4. In 4, we need to find the volt. We need to convert everything connected to the 6 mega ohm resistor. So we will do conversion for all this. So here we combine all them together. So here what should we do here? So here you can see that we need to combine this together to form a voltage source and to form a voltage source and a resistor. So here we started here. So this becomes 20.25. 20. Just to check all the results, please. So this becomes in series with the 0.7. So 7.7 mega plus 3.5 mega. So becomes 4.25 mega ohm. And here also we will convert this to a current source in parallel with a resistor. So the resistor here becomes 1.2 mega and the current source will be downward here. This will equal 15 over 1.2, so it becomes 12.5 micro. 12.5 micro. So here, then we complete the circuit, the 7 and the 6 mega ohm. 7 and 6. Now here we can do again source transformation to this voltage source and this resistor. So we will find this is equal to current source 4.675 microamp in parallel with 4.25 mega ohm and also 1.2 mega ohm, and also don't miss the current here. This current becomes 1 point becomes a 12.5 micro amp here. Then we have the 7 mega and 6 mega. 7 mega and 6 mega. Now it's clear we can combine the two current sources, and we combine all the to the resistors, and we just leave the 6 mega ohm. So we find that this becomes one current source. We combine this together, one up and one down, so it becomes 7.735 micro. Then this in parallel with 0.825, 0.825 mega ohm, and we have here our 6 mega ohm. Now this can be converted to a voltage source equal 6.385 volt, and this is the 6 mega ohm, and this voltage source will be just this resistor, which is 0.825 mega ohm. So the power dissipated in the 6 mega ohm will equal 5.25 microwatt. So please check all this answer. So we go to the question number 5. Question number 5 is just, I think it's just straightforward, but it's very, very long. It's very, very long because you need to do a source transformation many times. So we need to find Ix. So we will convert all this. So we convert the 12 volt and 47 to a resistor, to a current source and resistor in parallel. Then we combine 47 with the 22. Then again, we will convert this current source with this resistor to a voltage source and the resistor in series with 10. So we combine the 10 and this resistor, and we do this again and again until we reach to only one voltage source and one resistor. So I will give you the final circuit. I will give you the final, and you have to work on it. So I will end up with just a voltage source 0.351 volt and a resistor 7.227 ohm, and with a resistor 17 ohm. So it's clear that Ix will be just this voltage over the total resistor. So the power in the 70 ohm will equal 3.563 milliwatt. So this is the power dissipated in the 17 ohm resistor. So the last question, we have a dependent. So yeah, we need to find the power. So now we need to find Vx. We need to find X using source transformation, which is actually the voltage across the 4 ohm resistor. Vx is the voltage across the 4 ohm resistor. Now here, please pay attention that now here you have a dependent variable here. So this resistor cannot be combined with any resistor. So what I will do here, I will try to make my circuit into parts. So I call this is first part. I will combine this to a voltage source. I combine this together. I combine this together, and I will bit everything later together. So I will start by combining this. So this will be combined to 3 amp times 1, so it becomes a 3 voltage source. 3 voltage source in a combination with 1 ohm and 2 ohm and 7 ohm and 7 ohm. Again, I will combine this 3 and this becomes 3 ohm, so they become just a current source. To up, it's 1 amp because 3 over 3. Then here I will have 3 and 7. 3 and 7. This together will become 2.1 resistor. Then this 2.1 resistor I multiply by the 1 amp. I will find that this will equal 2.1 volt in series with 2.1 ohm resistor. So I converted now this part. This part we have 10 and 10 become 5, so 5. Then we have this 5 ohm and 5 Vx. Now you can do the source transformation for any source that has a dependent variable. The thing that you should not play with is the resistor that has the dependent variable, the 4 ohm. The 4 ohm we cannot approach it. So this becomes 5 ohm resistor in parallel in series with a voltage source. 5 times 5 equal 25 Vx. This one is easy, just 9 ohm times 9, which is equal 81 volt. So my complete circuit will be this one is, or this part becomes 21 volt in series with 2.1 ohm. This part becomes 5 ohm and minus 25 Vx. And here is my Vx 4 ohm, and this is my Vx. This one becomes 9 ohm in series with minus plus 9 times 9, 81 volt. So this is my complete circuit. So from this circuit I can assign a current I. Because we need to find X, yes. Then I can write my KVL equation. So here minus 2.1 plus I 2.1 plus I times 5 minus 25 Vx and plus Vx plus 9 times I minus 81 equal 0. And remember the relation between Vx and I. We know that Vx equal 4 times I, because the current here. After you solve this, you should get Vx equal minus 4.16 volt.